Hey everyone, today we are going to solve the Daily LeetCode challenge of 19th March 2024 and the problem statement is task scheduler. So let us first understand the problem statement. So according to the problem statement, we have been given an array of string such that each element of this array represent a task that need to be processed by the CPU. Okay, and each of these tasks take 1 unit of time for its completion. Fine. And we have been given another integer variable n such that this n represents the cooldown period. Now, what is a cooldown period? So, a cooldown period means, say for example, this task A has been given the CPU and it has been completed. So, it will have to wait for 3 units of time to get the CPU again. That is, if we have a CPU over here and if we assign the CPU to task A, then it will have to wait for this 3 units of time. And once this 3 unit of time gets completed, then we can assign the CPU again to another task A. That is, we have given the CPU to this task A, then it waited for 3 units of time. Then we gave the CPU to this task A, and again it has to wait for 3 units of time. And once the 3 units of time passes, what we have to do, we can again give the CPU to the task A, correct? So this n is the cooldown period. That is the time for which a task has to wait in order to get back the CPU, correct? Now, what we have to find out? We have to find out that what is the minimum time that we require to process all these tasks. Okay, let's see what would be the minimum time to process all these tasks. So if we have a CPU over here, so what we can do is we will be assigning the CPU to the task that has the max frequency. Okay, I'll be explaining the reason very shortly. So here we can see that A has a frequency of 3, B has a frequency of 3, and C has a frequency of 2. So the max frequency is 3 and both A and B are having it. So what we can do is we can choose any one of them. So I'll be choosing A. So we can give the CPU to A. Then what will happen? It will have to wait for 3 units of time. So it means that for 3 units, the CPU is idle over here. And what we will do, we will assign A again. Correct? Now again, it will be idle for 3 units. After that, what we will do, we will assign A again. Correct? Now, we have assigned all these 3 A's to the CPU. Now, what we have to do is we have to process these B. Now, what we can do is we can place a B over here and it will have a cooldown of 3 units. So, what does it mean? It means we can't place a B over here, we can't place a B over here, we can't place a B over here. So, these 3 units have been passed. Now, we can place a B. Okay. Now, again, we will have 3 units of cooldown. So, we can't place a B over here, we can't place a B over here, we can't place a B over here. Now, 3 units of cooldown have been passed. Now, we will place the B. Now you can see that we have successfully placed 3 of the B's. So we have placed A, we have placed B. Now we are left with placing this C. So let's see, here we will place this C. We can't place C over here. We can't place C over here. We can't place C over here. So this 3 units of time have been passed. Now we can place a C. So we can see that we have successfully placed these 2 C's as well. Correct? Now what does these empty boxes means? These empty boxes means that for this particular time period, our CPU would be idle. Now, what does it mean? It means that our CPU would neither be processing task A nor task B and C. Correct? So, it means that none of the tasks would be processed by the CPU at these particular time interval. Right? Now, I was telling that why are we starting with the element with the max frequency? It's because if we start with an element with the max frequency, then it is pretty sure that the element which would be processed at the last by the CPU would be the element with the max frequency. So here we can see that the element with the max frequency is A. But is A the element to be processed last by the CPU? So the answer is no. You will say that B is the last element to be processed by the CPU. So you are also correct. Why? It's because B is also having the frequency of 3. Correct? So it means that whichever elements has the max frequency, it would be the last element to be processed. And once this last element has been processed, we won't have any idle time over here. Why? Because this is the element with the max frequency. So once this has been completed, so it means that there are no more tasks, right? So that's the reason we will be starting with the element which has the max frequency. So what is the time required to process all these tasks? So the minimum time required to process all these tasks would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are using 10 units of time to process all these tasks, out of which the CPU is being held idle for 2 units. So we can see that for 2 units of time, the CPU is idle and rest 8 units of time is being used by the task. So we can see 1, 2, 3, 4, 5, 6, 7, 8. 8 units of time have been used by the task to process in the CPU. And for 2 units, the CPU is idle. So the total time would be 10 units. Okay. Now let's see how we can solve this problem. We will solve this problem by finding out the idle slots. Idle slots. And once we will find out the idle slots, what we will do, we will fill it. Okay. Now let's see what do I mean by that. So first of all, we need to find idle slots. So let's see how we can find idle slots. So for finding out the idle slots, what we will do is we will first store the frequency of each element. Store frequency of each task. Now let's store the frequency of each task. So we can see that what is the frequency of A? The frequency of A is 3. What is the frequency of B? The frequency of B is 3. And what is the frequency of C? The frequency of C is 2. Okay. Now we are done with the first step, that is storing the frequency of each task. Now what we will do after that, we will find the max frequency. Okay. We will find max frequency. So what is the max frequency? Out of 3, 3, 2, the max frequency is 3. So our max frequency is 3. We got max frequency as 3. Now once we have found out max frequency, what we will do? We will find out idle time. Now how are we going to find out this idle time? So let's see. So we wrote a over here, we wrote a over here, and we wrote a over here. So out of how many A's are we having idle slots? So after this A, we were having idle slots, correct? That is, initially we wrote 3 of the idle slots for this A, right? And after this A, we were having 3 of the idle slots, correct? But did we had any slots after this A? No. And what is the reason? The reason is that since this A has the max frequency, so it is sure that this A would be the last element to be processed by the CPU. Or if we have any other element except this A that has the same frequency, that is, in this case, we can see that B is having the same frequency as that of A. So in that case, that element would be the last element to be processed by the CPU. But in any of the cases, we won't have any idle slots after these elements. Why? Because they have the max frequency. So there would be no elements left which would come at the last. So we won't have any idle time at the very last. Okay. So after how many A's are we having idle slots? Only after these 2 A's we are having these idle slots. Correct. So what we will do is we will find idle slot, and the formula for finding idle slot is max frequency minus 1 into n. And once we have find out the idle slot, what we will do is we will fill it. Now how are we going to fill it? For filling it, we will be iterating over the frequencies of the elements starting from the max frequency to the lowest frequency. Why? It's because what we did over here, we first filled A. Why A? Because it's having the max frequency. After that, we filled B. Why B? Because it's having the second max frequency, or we can say that B is having the same frequency as that of A. And lastly, we filled C because it's having the lowest frequency. Correct. So we start filling with max frequency to lowest frequency. Correct. Okay, now let's quickly do a dry run. So what is the first step? First is to find the frequency. Okay, so what we will do is we will create a vector to store frequency. Okay, so let's say in the 0th index, we will be storing the frequency of A. In the first index, we will be storing the frequency of B. And in the second index, we will be storing the frequency of C. Now, what is the frequency of A? The frequency of A is 3, right? We can see we are having 3 elements. What is the frequency of B? The frequency of B is also 3, correct? Now, what is the frequency of C? The frequency of C is 2, so we will write the 2 over here. Now, once we have stored the frequency, what we need to do? We need to find the max frequency. Now, how we can find the max frequency? We can simply sort this array. So, once we will sort this array, what we will get? We will get a 2 over here, 3 over here, and a 3 over here. Why? Because we have sorted them in ascending order, correct? So once we sort them in ascending order, then what is the last element? The last element is the element which has the max frequency. So what we have got is our max frequency is 3, correct? Now once we have got the max frequency, what we were supposed to do? We were supposed to find the idle time. And what is idle time? Idle time is max frequency minus 1. What is max frequency? Max frequency is 3. So it would be 3 minus 1 into n. What is n? N is 3. Okay. So we will multiply 3. So what we will get? We will get 2 into 3, that is 6. Now let's see how are we getting this 6. So if we have a CPU over here, so we choose that this 3 is the max frequency, correct? And which element is having the frequency of 3? Both A and B are having the frequency of 3, right? So we can choose any one of them. So I am choosing A. So if I assign the CPU to A, then we can't assign the CPU to A till 3 units of time passes. Why? Because 3 units of time is the cooldown period. So let these box represent the 3 units of time. Okay. So once this 3 unit of time passes, what we can do? We can assign the CPU to A, and again 3 unit of time would be there as the cooldown period, and again we can assign it to A. Fine. Now we have assigned the CPU to A, and we can see that how many slots do we have? We have total 3 plus 3 slots, right? We have 3 slots over here. We have 3 slots over here. So in total, how many idle slots we are having? We are having 3 plus 3, that is 6 idle slots. So these are the idle slots, right? These are the idle slots. So we have 6 idle slots. Now what do we need to do? Now once we have found out this idle slots, we need to fill it. How are we going to fill it? Now we discussed that start filling it from the max frequency to the lowest frequency. So it means that we will start filling it from the right side. Now we can see that we have used this 3. How we have used this 3? We have already placed these A over here, right? We have already placed these 3 A's, and now we only need to fill this empty places, that is the idle slots. So for filling the idle slots, what we will use? We will use this B and C, correct? So we will start iterating from here. Fine. And what we will do? We will start filling them. Now how are we going to fill? For filling them, we are going to find out the minimum of the frequency of I, that is the frequency of current element, comma, max frequency minus 1. Now, why are we doing this? That is, why are we finding out the minimum? So it would be clear soon. So at this point, what we will do? We will find the minimum of current frequency of current element. So what is the frequency? It's 3, comma, what is max frequency minus 1? It's 2. So what's the minimum? The minimum is 2. Now, what does this 2 mean? This 2 means that 2 B's are consuming the idle slots. So if we will start placing the B, so how we will place it? We will place a B over here. Then it will have a cooldown of 3 units. So we can't place a B here. We can't place a B here. We can't place a B here. Now we can place a B over here because 3 units have passed. Now we can't place a B here. We can't place a B here. We can't place a B here. Now we can place a B here because 3 units have been passed. Correct? So how many idle slots are we consuming out of the 6 idle slots? We are consuming 1, 2, only 2 idle slots, right? This B is not present in any idle slot. Correct? So what we will do, since 2 idle slots have been filled by this B, so what we will do is we will subtract this 2 from the idle slots, right? So what was the idle time? The idle time was 6. That is 6 was our idle slot. So let me write it over here. So idle slots was 6 in total. Now out of this 6, these 2 places have been consumed by the B. So what we will do? We will subtract 2. So we will get a 4 over here. Now what we will do? We will move here. Now we have 2. So what we will do? We will find out the minimum of 2, 2. Now what is this 2? This 2 is the frequency of current element. And what is this 2? This 2 is max frequency minus 1. So what would be the minimum? The minimum would be 2. Now what does this 2 represent? This 2 represent that 2 slots have been consumed by C. Now let's see. If we will place a C over here, then it will have a cooldown of 3 units. So it means we can't place a C here. We can't place a C here. We can't place a C here. Now 3 units have been passed. Now we can place a C here, right? So how many slots is this C consuming? The C is consuming 2 empty slots, that is 2 idle slots. So what we will do? Since 2 idle slots has been consumed by this C, so we will subtract 2 from here. So what we will have? We will have 2. Now what does this 2 represent? This 2 represent that only 2 slots have been left idle. And what are those 2 slots? It's this one and this one. And we can clearly see that we are left with 2 idle slots, correct? Now, since we have 2 idle slots, so what would be our answer? Our answer would be the time required to process all these tasks. Since one task take 1 unit, so how many unit of time will all the tasks take? We have in total 8 tasks, so they will take 8 unit plus the idle time. What is the idle time? The idle time is 2, correct? We can see that 1 unit is here, 1 unit is here, plus 2. So what we will get? We will get 10 unit as the answer. Additionally, we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units is required to complete all the tasks of this array. Correct? So what we were doing? We were first finding out the idle slots. And how are we finding the idle slots? For finding the idle slots, we are first storing the frequency of each of the element, correct? Here we store the frequency of each of the element. Now we want the element with the max frequency. And why do we want the element with the max frequency? The reason is that if we will use max frequency to find out the idle time or to find out the idle slots, then it is pretty sure that that element would be the last element to be processed by the CPU, correct? So what we did, we simply sorted this array in ascending order so as to get the max frequency. And what would be the max frequency? The max frequency would be the last element because it's sorted in ascending order, right? Now, once we got the max frequency, what we did, we found out the idle slots or idle time, correct? That is how many number of slots are there for which the CPU would be idle. So how did we calculated it? We multiplied n with max frequency minus 1. Now, why did we did max frequency minus 1? Because what was the frequency of A? The frequency of A was 3, right? 1, 2, 3. And after how many A's were we having idle slots? After only 2A, that is after this A and this A. So we can see we had 3 slots over here and we had 3 slots over here. And why didn't we had any idle slots after this A? The reason is that since this has the maximum frequency, so we are sure that we won't have any elements towards its right. So it means we don't need any empty slots towards the right, correct? So once we have found out the idle slots, what we have to do, we simply have to fill it. And how are we going to fill it? We will start filling it from right to left. That is, we will start filling from the max element and we will move backward, correct? So we understood that what we are returning the idle time plus the time required by all the tasks in the CPU, right? That is, this was the time which is required by all the tasks and this was the idle time, and we got the answer. But let's see one more test case. So let's see whether it will work in this test case. So here we have task as AABC and the cooldown period is of 1 unit. Okay. So let's store the frequency of each task. So what is the frequency of A? The frequency of A is 2. What is the frequency of B? The frequency of B is 1. What is the frequency of C? The frequency of C is 1. We are done with first step. What is the second step? To find the max frequency. How are we going to find the max frequency? We are going to sort this. And after sorting this, what we will get? We'll get 1, 1, 2, correct? Because it is sorted in ascending order. And what would be the max frequency? Max frequency would be the last element, correct? So we have max frequency as 2. Now what are we going to find? We are going to find the idle slots. Now what would be idle slots? Idle slots would be nothing but max frequency minus 1. So max frequency is 2. So we have 2 minus 1 into n. So n is 1. So what we will get? We will get a 1 over here. And I already explained that why are we doing this max frequency minus 1, correct? Because after this last element, we are not going to have any idle slots. That's why we are doing this frequency minus 1 over here, correct? Now, once we have done this, what we have to do, we have to fill this idle slots. And how are we going to fill this idle slots? So if we have a CPU over here, so what we will do, we will assign the CPU to A. Why to A? Because A is having the max frequency, so we will be assigning CPU to it first. And then we will have a cooldown of 1 unit because n is 1. Then what we will do, we will assign the CPU to A again, correct? Now let's see. Now we have assigned the CPU to A, so we won't start iterating from here because A has already been assigned the CPU, so we will start iterating from here. And what we will do is, we will find the minimum of frequency of current element, comma, max frequency minus 1, fine. So what is frequency of current element? The frequency of current element is 1. What is max frequency minus 1? Max frequency is 2. So 2 minus 1 is 1. So what is the minimum of them? The minimum of them is 1. Now what does this 1 indicate? This 1 indicates that one idle slot has been consumed by this B. Right? So we will place a B over here. And we will subtract 1 from here because 1 slot has been consumed. So what are we left with? We are left with 0 idle slot. And we can clearly see that we don't have any more idle slots, right? Now we will come over here. And what we will do, we will find the minimum of current frequency is 1, comma, max frequency minus 1 is 1. So what we will get? We will get 1. What does this 1 indicate? It indicates that an idle slot has been consumed by this C. So what we will do, we will place C over here. And why are we placing this C over here? Because we can see that we are not having any idle slot, correct? And if we will subtract this 1 from here, so what we will get as idle slot? We will get minus 1 as the idle slot, correct? Which is wrong. Okay. So whenever we will find out that we have idle slot such that it's negative, that is whenever we will have idle slot less than 0, in that case what we will return? We will simply return the length of task. And what is the length of task? In this case, the length of task is 4. And what is the time that is required to complete all these tasks? We can see that it's 1, 2, 3, 4. Correct? So now we are done with this approach. So let's quickly code this. So we will start on by taking a variable time which would be initially 0. This time represent the minimum number of time that would be required to complete all the tasks. Okay. Now we have to store the frequency of all the elements. So for that we will take a vector. Let's name it as frequency. Its size would be 26. Why 26? Because in total we have 26 alphabets. Correct. Now what we have to do? We have to populate the frequency. Correct. Because what was our first step? Our first step was to store the frequency of each of the tasks, right? So what we will do? We will iterate over them to store the frequency. So we will say for auto current is to task. What we will do? We will say frequency of current minus A plus plus. Now, why are we doing this current minus A? Say for example, if our current task is A, so what would be A minus A? A minus A would be 0. And if our current task is B, then what would be B minus A? B minus A would be 1. So what does it mean? It means that we are storing the frequency of A at the 0th index, frequency of B at the first index, frequency of C at the second index, and so on. Correct? Now, once we have populated the frequency, what we want to find is we want to find the max frequency. And for that, what we will do? So we will sort them. So we will say frequency dot begin, comma, frequency dot end. Okay. Now, once we have sorted this, what we want the max frequency. And which element will have the max frequency, or where would be the max frequency stored? The max frequency would be stored at the very last index. Why? It's because now we have sorted the array in ascending order, correct? So we want frequency at the 25th index. Now, once we have found out the max frequency, what we want to find the idle slot or the idle time, correct? So what would be idle slot? Idle slot would be nothing but max frequency minus 1 into n, correct? So we will multiply n over here. Now, once we have found out idle slot, what we have to do? We have to fill it, correct? And how are we going to fill it? We will be start iterating from the second last index up to the 0th index, and we will find the minimum of frequency of current element and max frequency minus 1, right? So what we will do? We will say for index equals to, we will start from the 24th index. Why? Because we have already assigned the CPU to the 20 element present at the 25th index, correct? We will say index greater than equal to 0, index minus minus, and we will say idle time minus equal to minimum of max frequency minus 1, comma, the frequency of the current element, correct? Now, once we have found out the idle time, what we want to check? We want to check that if this idle time is less than 0, in that case, what we will return? We will simply return task dot size, correct? Otherwise, what we will return? We will return the sum of the idle time and the size of task, correct? Now, let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now, talking about the time complexity and space complexity. So if we consider m as the size of task, that is, if we consider that there are total m tasks present in this vector, then the time complexity would be order of m. Why? So we can see over here that what we are doing here, we are iterating over all the elements of this task array, correct? So it means that if we have m elements present in it, so we are iterating m number of times. So that's why the time complexity is order of m. Now you may ask that here we are sorting, and sorting takes how much time complexity? It's take n log n time complexity, correct? Where what is this n? This n is the size of this frequency. And what is the size of this frequency? The size is 26. So what is this? It will boil down to 26 log 26, correct? And this 26 log 26 is a constant term. So 26 log 26 plus order of m will give us order of m only, correct? And the space complexity is order of 26. Why? So it's because we are using a frequency vector of size 26. So that's all about today's daily LeetCode challenge. Thank you.